Last week, we introduced a rectangular prism, which we learned is basically the fancy math word for a box. And we learned about the volume of a rectangular prism. So that's the amount that we need to fill up the inside of the box. So we learned that the formula for that was length times width times height. What we're going to talk about today is what's called the surface area of a rectangular prism. So if you want to put that into some everyday, easy to understand context, surface area is if you thought about wrapping a box. So if you think of like wrapping a present in a box. So surface area would be the equivalent of how much paper, how much wrapping paper it would take to wrap the box. So basically surface area is how much does it take to go all the way around all of the outside surfaces of the box and completely cover the box. So the way we find that, if you think about wrapping paper, wrapping a present, you want to cover all of the different sides of the box so that everything is completely covered up. So surface area of a rectangular prism is the total area of all of the, we call them faces, but they're actually sides, all of the faces of the rectangular prism, or all of the faces of the box. So a box has a front, a back, a left, a right, a top, and a bottom. So if we wanted to completely wrap that box up, we would need to cover all 6 of those sides. So surface area is going to be how big all of those sides are together so that we know how much it would take for us to completely cover our box. So the way we find surface area is by actually finding the area of each of the different sides. So if you think for the wrapping paper analogy again, how much paper would it take for me to cover each side? And then we add it up, and that gives us the total amount that it would need to cover all of the sides. Now, before we go in and start calculating how big each side of our box in our example is, to give you a nice worked out example of surface area, I'm going to go through and I'm actually going to color code some things because it's going to help you to keep track of what's going on. So the width across the front of the box right there, that's 10 inches. So when we label things, we usually only label one of each type of measurement, but the thing you have to remember is that if that edge is 10 inches, all of the other edges that are running the same direction as that are also all going to be 10 inches, even though they're not labeled. So those purple edges are all the same length. We can go through and we can do that with some of our other sides too. So the box has a height of 4 inches. So that side is labeled, but that means that all of the other sides that are running the same direction as that are also going to be 4 inches, even though the 4 inches isn't written out. So we have to remember that because it's going to help us in just a minute. And then again, the length of the box is 3 inches. So all the other sides running that same direction are also going to be 3 inches, even though they're not labeled. So all the purple sides are the same length, all the green sides are the same length, and all the orange sides are the same length. So I labeled it just to make it a little easier to keep track of, and I'm going to be using that labeling as we walk through this example too, just to help you keep track of what pieces of our rectangular prism or our box we're looking at. So you don't have to go through and color code like I did, but when you get to the end of this, if you think that that's something that might help you, then that is something that you can do when you're working on your practice problems, is go through and color code the matching measurements just to help you keep track of things. So I am going to go through really quickly, and I want you to do the same thing in your notes. And I'm going to sketch just some quick pictures off to the side that we can label. So the front of the box and the back of the box are the same size. So the front and the back of the box, they're going to look kind of like this. So the front of the box has the purple side, and then it also has the orange side. So that means that the front of the box is going to be 10 inches by 4 inches. So if you kind of grab those measurements. So that would be the front. It's also going to be the back of the box. So the lefts and the rights of the box, so those are kind of the sides of the box. So those look a little bit more square shaped. And those are made up of a green measurement and an orange measurement. So those are going to be 3 inches by 4 inches. So that's the left and the right. Now the top and the bottom of the box are also the same size. So the top and the bottom of the box kind of look, move that out of the way, kind of look like longer rectangles again. So the top and the bottom of the box are made up of a purple side and a green side. And so you can kind of see we're pulling each of the measurements out and we're labeling it. So that's going to be 10 inches by 3 inches. So what we did is we just went through and we drew a picture of what the front and the back of the box look like, what the left and the right of the box look like, and what the top and the bottom of the box look like. So this is going to be the front and the back. This will be the left and the right, and then this will be the top and the bottom, because again, front and back are the same, left and right are the same, top and bottom are the same. So now what we're going to go through is we're going to go through and find the area of each of those sides one at a time. So remember, to find the area of a rectangle, area is length times width. So the front of the box is 10 by 4. So we're going to do 10 times 4, which is 40. Now I'm not putting units on here yet because we're calculating, but when we're done, we're going to put the correct units on our answer. The back of the box is the exact same size, 10 by 4, so that's also going to have an area of 40. So the front has an area of 40, the back has an area of 40. Now we're going to do the left and the right. The left and the right are both 3 by 4, so length times width is going to be 3 times 4, which is 12, and then the right side is going to be exactly the same because it's the same size as the left. So the left and the right are each have an area of 12. Now we have to do the top and the bottom of the box. So the top and the bottom of the box are 10 by 3. So if we find the area of that, 10 times 3 is 30, and the bottom of the box is the same size. So it's also going to be 30. So we've got the area of each of our sides. So 40, oops, a little bigger. 40, 40, 12, 12, 30, 30. So now what we want to do, so that's each of the individual sides of the box. So it's what it would take to cover each side. So surface area is the total of all those things. So that's what it takes to cover each side. Now we're going to add them up, and that's going to give us the total that it would take to cover all of the different sides of the box. So this is now going to turn into a big old adding problem. So 40 plus 40 is 80, 30 plus 30 is 60, and then 12 plus 12 is 24. So you can add it up that way. So you can add these up in any order you want, but you get a total of 244. So now we need to talk about units. We want to make sure we want to get the right units on our answer. So when we're working with, and we're actually going to label the units on this in just a minute, but I want to come down to the bottom for a minute. What units do I use? And that'll help us get the right units on our answer. So we actually have 3 different types of units that we use when we're calculating things. So we have length units. So length units are what we use to measure straight distances. So a good way to think, is it a length unit? If it's something you can measure with a ruler or a tape measure, it's a length unit. So the units are just going to be whatever the regular units are. So if you're measuring in inches, then your units would be inches. If you're measuring in feet, your units would be feet. Area units. So area is used to find the amount of space that a flat object takes up. So that would use square units. Or another way of thinking of it, if you wanted to write it differently, would be units and then with a square symbol. So you could say square feet, or you could say feet with a square symbol. That also means square feet. So surface area is a type of area measurement, because surface area, we're measuring the flat sides of each box. So area includes, oops, sorry about that, didn't mean to send that flying. So area also includes surface area. Now the last one is volume units. So volume is what it takes to fill up a 3-dimensional object. So volume units would be cubic units, or if you wanted to write it the short way, whatever your units are with a cube symbol. So if you're measuring in volume in yards, you could say cubic yards, or you could abbreviate and say yards cubed. Those both mean the same thing. It's just preference whether you want to write it out or whether you want to abbreviate it. So since we just calculated surface area, back up to our answer up here, we want to use square units, or units squared if we want to write it out that way. Since our units are in inches, we're going to do square inches. So you can literally write out square inches, or you can write it the short way, which would look like this, inches squared. So one thing that I'm going to be looking for when you guys are working through, because we've talked about area and surface area and volume, is that you're getting the correct units that match the type of calculation on your work. So if you're working with surface area, you should be using area units because you're measuring flat two-dimensional surfaces. Each side of the box is a two-dimensional surface. So that is how you calculate surface area of a rectangular prism, also known as a box. So this should give you a nice worked out example of how that works. And now you're going to take this and you're going to try this with some of your practice problems. And again, if it helps you to color code your work to keep track of what you're doing with each side, then feel free to do that in your own work if you think it's helpful. You don't have to, but if you think it'll help, then you're welcome to do that.